this computer. All right. Okay, so again, this is the Metalwork Merit Badge for our Dynamic Skills Merit Badge Day that we usually have every October. So you could always come back next October and do another one. But requirement number 1. So on your packet, requirement number 1 says to read the safety rules for metalwork and discuss how to safely work with metal. So I basically, these 10 points of rules are in the book of your pamphlet. If you didn't read through it, it's really interesting. I read a lot of it to prepare this, and I learned a lot. So hopefully you guys, if you don't have it already, you do get that and read through it. Number 1, obviously, always work with adult supervision. That's a given. We're scouts. We know that. Number 2, we always wear our safety goggles, our leather gloves, and an apron, which, by the way, we do provide all of that. When you come on Saturday, we will have the goggles, the leather gloves, and the apron. Number 3 is handle sheet metal with care. Obviously, because sheet metal, once you like bend it or anything, it has nicks, so they're called buffs, and so they do cut, and it hurts. It's worse than a paper cut. Number 4, treat every cut immediately. No matter how small the cut may be, even if it's just a tiny cut on your hand or anywhere else, you must treat it immediately. Wash it, soap and water, because it can get infected. Number 5, remove all burrs from the sheet metal before working on it. Again, those are, you'll see them on sheet metal or any kind of metal, like little rough. It looks like it's just rough, but you never take your bare hand, which is the next one, number 6. Never run your hands over sheet metal, because those little burrs, it's almost like, I guess I could like it to fiberglass maybe. You can't see it, but it'll hurt, okay? Number 7, never use your hands to clean off your work area. Always use a brush, like a wire brush or something, and scrape off all the little pieces of metal. Anytime you're cutting metal and you have scraps, which is a lot, you always put them in a scrap box right away. Okay, never leave them laying around, because it can cut someone, or if it gets knocked off, it can land on your foot or something like that. Number 9, always check your tools. Make sure the tools are in good condition. Okay, never use, like, you know, hammers, the handles can get loose. So never use tools that are not in tip-top shape. And number 10, always clean the floor and the work table and all your area after you're done working with metalwork. And again, it's so that those burrs and all those other pieces of scraps somebody else doesn't come and hurt themselves. Okay, so that was that one. Then you were supposed to talk about the additional safety rules for the project that we're doing for number 5, and we will be doing blacksmithing. Okay, so for that bottom part of page 1, you will be talking about the additional safety rules for blacksmithing, which again, always work with adult supervision. This one, you always want to have a fire extinguisher handy, and there's certain fire extinguishers, and Anthony will have that available as well. Number 3, again, wear safety glasses, your leather gloves, your shop apron. Now here's a little bit more. We're all going to be wearing long pants, which can be jeans. That works good. And boots work better, but definitely no shorts and no sandals. Okay, so boots or hard top shoes. Like, you know, a lot of people have them. Hiking boots, those work good too. Just regular tennis shoes probably aren't the best thing, because if you drop a piece of metal onto your foot, number 1, it could burn through if it's hot, if it's been in the fire, or it could, if it's sheet metal, it could go through and cut your foot. So you should have really good shoes or boots. Number 4, allow the hot metal to cool in an out-of-way place. And the ones it took, and number 5 along with it, use tongs to pick up a dropped object. In welding, they learned this last week, that, you know, when metal's hot, it might not be a different color. It might be the same color as when it's not hot. So you always got to be really careful and keep it, you know, cool it off in an outer way place, meaning so nobody touches it, especially yourself. And use tongs whenever you pick one up or drop it, because We only have a habit, we drop something, we reach down and pick it up. We never want to do that when we're working with metal, because it could definitely still be 1,000 degrees. All right, so that was all of number 1. Requirement number 2 on the next page, you're supposed to define these terms. These terms are actually pretty simple. A native element, you think about that. If it's native, it naturally belongs here. So any metal that occurs naturally, okay, in a near, pure state, okay, of form. Malleable, it means you can take a hammer and it's capable of being shaped. So you're going to be doing that actually in class on Saturday. You heat up the metal, and if you can hit it with a tool and it can, bend its shape and all, then the metal is malleable. Okay, like a mallet is a hammer, right? Malleable. You think about it. Metallurgy. That a metallurgist is a person that studies the properties of metals. So metallurgy is a study of the properties of metals. Okay. Alloy. Now, alloy, if you're familiar with chemistry, so I know there's a lot of high school kids in here, so if you've taken chemistry, you know when you mix 2 chemicals together, you get a different chemical, right? An alloy is kind of the same. It's a metal mixed with other metals or substances to change the properties of the metal, okay? Non-ferrous. We know the prefix non means not. So a non-ferrous metal means one that does not contain iron. So ferrous means iron, okay? So no iron is a non-ferrous metal, whereas ferrous metal is one that does contain iron, all right? Any questions so far on number 1 and 2? All right, so the second part of number 2 on the next page of your workbook, on page 3, you're supposed to name 2 non-ferrous alloys. Now remember, these are metals that are made with 2 other metals that do not contain iron, okay? And the pre-iron age, so this is before iron was available, the pre-iron age. 2 non-ferrous alloys that were made then and used. 2 examples in the book were bronze and brass, as you see on the screen. Bronze is a combination of tin and copper, whereas brass is a combination of zinc and copper. Okay, so they took copper and they mixed it with other metals to create a new metal, which was an alloy. All right, and the second part of that one was naming 3 ferrous alloys. So these are 2 alloys that contain iron, okay? But they're not iron, they're a new iron, I guess you say. And these are used by modern metal workers. A lot of us have products that have these in them at home right now, especially in the kitchen. Carbon steel, stainless steel, and cast iron. As a scout, you've seen cast iron used many times with a Dutch oven. I forgot the name. Okay, so Dutch ovens made out of cast iron. So we know these can be heated really well and used. All right. So part C, it says describe how to work harden a metal. And it's actually in the book, the pamphlet on page 21. And the next part was describe how to anneal a non-ferrous and a ferrous metal. And that's on page 22 and 23 in your book. I did find some videos here that I'm gonna play. So bear with me. Hopefully you'll be able to hear them. Can you see the video?
Hi, and welcome back.
Yeah?
Today I'm going to be doing a very simple demonstration.
No, I can't see the video.
Metal does indeed
Could you
work
see the
hard.
video?
You have to stop sharing and then share the screen that it has the video on it.
Metal up to a forging temperature, and you work with it.
You know what? What I will do is when you get, I'm going to send this PowerPoint to your parents' email. And when you get it, you can click on this link and watch this YouTube video. And there's another one down here. But wood hardening a metal, like I said, on page 21 in the book, if you have it, you'll see that wood hardening is the process of hardening a metal.
Very carefully at
So
that
you have-
temperature. Don't let it cool
Hold on.
down too much. There is still stress.
Maybe you could pin the link to the video in the chat.
Okay, I could do that. I could do that.
I mean, the other option is have the video up on another
There is
screen
going to be doing
and then stop sharing this screen and then go to the video.
the same way it would when you
This one off, and then go back to there.
Hi, and welcome back. Today I'm going to be doing a very simple demonstration to show you that hot metal.
Keep trying to play the videos. All right, let me go into the chat. That is one of them. I did the same. I did the same one. Hold on. It's the same one. Okay. There we go. All right, so I put the two videos in the chat. You can watch them later if you want to. But wood hardening a metal, again, in the book, it'll talk, you want to talk about that real quick, about wood hardening. Ranger Anthony will talk about it. They couldn't see the video.
Oh, bummer. Okay. Okay, work hardening steel, hardening metal. Basically is when you're taking a piece of something like copper and you're pounding it. As metal is pounded, with the exception of a couple of other metals, what is it here? It'll come to me. Mercury and lead. Okay, those get soft. They're just real soft metals to begin with. But something like copper, like as it shows in your book, as you pound it, actually does get harder. It strengthens it. To understand what's going on inside the metal, you got to understand you're rearranging molecules. As you heat and you cool, those molecules lock differently. So again, if you heat really fast, molecules move around. As they cool down, they come together and they take a shape or a form, or they bind, okay? Or they'll separate faster. If you cool them too fast, your molecules are doing this and that, okay, and they're not as close together. As they slow cool, they come and bind together. So again, when you're doing work hardening, it's the same thing. You're taking the metal, you're heating it up, and you're pounding it, and you're strengthening it by doing this pounding on it and locking those molecules in. And you're working it till it gets harder and harder. So annealing non-ferrous metals, oh, did you want me to do that? No, okay. All right.
So annealing a non-ferrous metal and a ferrous metal, basically you're heating it up like Anthony was saying, you heat it up, and then if you see on page 22, it's going to talk about it, but on a non-ferrous metal, you have to cool it quickly, meaning after you get it, in the video that I sent you, they anneal it like a jewelry company. He took a piece of metal and he got it really, really hot with a blowtorch. And then after it got red, cherry red hot. So you're always gonna get them cherry red hot, okay? And when it got cherry red hot, he stopped and he put it into like a water bath, Okay, and he said to make sure your water bath, your bowl was made out of metal or glass so that it doesn't burst. Okay, so he put the metal inside there and it cooled off quickly. Now, mind you, it's still hot, but he cooled it and the red went away. Okay, now a ferrous metal, one that does contain iron, those, when you get them cherry red hot, you have to let it cool very slowly. Okay, the reason you do it slowly is because if you don't, it will get very brittle and it will break. Okay, so while it's getting cooled, you're gonna put it into like a metal box, or there's also an option that shows you in the book that you can put it in a box with clean, obviously, cat litter. Okay, so you get some cat litter, you put it in there, and that helps cool it down. That ferrous metal has to cool for about 8 hours. Okay, it's a slow process, but it's going to cool for a longer period of time before you start working with it again. Okay, so obviously we're going to be using non-ferrous metal because we don't have time to wait 8 hours. So we'll be annealing non-ferrous metals. And then, okay, so he's going to talk about what you'll be doing with that.
No, I'm going to add a little more about the cat litter analogy, okay? So again, as she was talking about slow cooling, the cat litter absorbs the heat. Once it absorbs the heat, then it allows the metal to cool to its surroundings. So as the metal cools, the sand or the gravel around it also cools, but allows it to be cool slowly. Give you a good example of how this works. In the things like the space shuttle or, you know, these booster rockets, they actually have big furnaces that heat those up. And I'm sure you're familiar with the space shuttle Challenger. Well, those booster rockets on the side of the Challenger are heat treated, and they go in this big furnace. And what that does, then it goes over and it actually puts them in, and they're built in sections, and those sections are probably about, you know, a story high. So again, they'll be put in the ground, they'll be sealed under certain conditions and allowed to cool very slowly. So what this does, it helps one in strengthening, it helps working the metal. So again, there's different processes, but that's what the whole sand and the process of cooling down is. Go ahead.
All right, any questions on that? Okay, we're good. All right. You guys will see this in action on Saturday. I'm gonna make a lot more sense. All right, obviously requirement number 3 is making, work hardening a piece of metal, and this is why you'll see it. And you know, this is, like I said, this is the fun part, and you're gonna do it on Saturday. All right, requirement number 4 is to define 3 career opportunities in metalworking, and then do your research yourself. So some ideas in the book are a gunsmith, a welder, founders, architect, and a sheet metal mechanic. Those are just some opportunities that you could use your metalworking skills in. Gunsmith, I think, you know, and a welder probably uses the most of the skills. A sheet metal mechanic is obviously going to be in high demand. You got to know how to work with it, and how to make, yeah, folding and all that stuff, kind of like you're folding the metal and everything that you'll be doing. So yeah, and then and number 5, you will actually, we're doing option number 4, so you can skip 1 through 3. We're doing the last option, you only have to do 1. We always do option 4 here at Trask, which is the blacksmithing. One of the things you're supposed to do is to name and describe the use of the basic blacksmithing tools. And page 74, I took a screenshot of that and put it on here, but there's some basic tools there. And yeah, and then that was the whole thing. So Anthony's gonna talk about what should we do on Saturday, talk about the tools here and everything else. Okay, so there you go.
What's the hard? Okay, so everybody knows what an anvil is, and obviously we're going to do this at Firestone, so it's going to be kind of difficult to take our anvils. Our anvils are very heavy because they're solid metal or solid steel. So again, here's in your book, there's a picture of an anvil. And usually they're mounted to something. And the reason they're mounted to something like a piece of wood is so that wood absorbs shock. So when you're working a piece of steel, you don't want it vibrating all over the place, or you don't want it bouncing all over the place. So it's usually on a, where's my list?
Huh?
You took away my list.
Just talk about it.
Oh, okay. It's usually on a stump or a piece of wood or something soft that will absorb the shock. Okay. All right. I can't see it because she took down the screen, but the hardy, it's for tamping or kind of folding. So if you're going to break a piece of metal or you're going to, bend it a certain way, it's basically, that's what it's for. Then you got your tongs. Okay. The tongs are real long because heat travels. And if those tongs are touching metal all day long, they get pretty warm. So a cross peen hammer, basically there's a ball peen, cross peen. It's just a hammer that is usually curved or concave. This helps in kind of folding and pounding. Now we're going to be using some sledgehammers because I like to beat the crud out of the metal. Because we're doing this off location, we're not going to have the heavy metal that we usually do. So we're going to probably have just some light gauge metal. Does everybody understand how gauges work? Metal comes in gauges, and it goes from 0 to like 30 something in gauges, okay? So 0 being super thick metal, okay? And then as you get further down the line, it gets really thin and it's finer or a lot thinner. Copper, tin, almost hair, like. So again, that's how gauges work. So your metal comes in different gauges. So if you're building something, let's say you're building a frame for a door, you have to determine what gauge you need to hold up whatever you're doing. We're building a block house or building on our gun range. So we have a frame for that. Well, the frame, a door frame is metal, but it has to be a certain gauge. And I believe that's probably about 18 gauge. So it's a little thicker than it would be if you went out and bought a steel stud or piece of metal. And I'll bring that on Saturday so you can see some different gauges of steel. Some are too thin to really work unless you're actively doing something specific. So what else? We talked about the anvil. We talked about, let me see, top leg. Kind of, what's that? Forge. You all know what the forge is, right? It's that thing, I like to call it the dragon. You stick your piece of metal in this hot, furnace, so to speak, and that's where you get this even distribution of heat, and it heats it up real fast. Now, we might be able to take the forge there. I'll have to look because I like it. It's really cool. It makes a lot of noise, and it gets everything really red hot. But if for some reason we can't get that there, we're not allowed to have it there, then we'll have a torch. And this is a good point for you who are, I think, those who are in Palmdale or somewhere like that. I don't think you're coming out Saturday because of the drive, and that's understandable. So as you watch the videos that linked, that Andrea is going to link or send to you, you can do those projects. Just have somebody with you, an adult, when you do it, so that you can see the difference between tempering and work hardening. They're pretty easy projects, and we might be doing some of those on Saturday also. We don't want to take up a lot of your time. So again, we're trying, because of the whole COVID thing, to keep everything to about 2 hours. That's why we are doing the Zoom, so we don't have to keep you there too long. And I think Miss Andrea said, wear your mask. We will have goggles for you. So again, she'll go over that real briefly. Are there any questions? I'm waiting. Okay. Forge, hammer. Oh, okay. So she says here, we will be making some metal product. Yeah.
Could you show the tools again?
Go over the tools.
Could you show the tools again, please?
Show the tools.
Yeah.
Okay. So the anvil,
Okay,
is
thanks.
a big steely thing. The vise, we have one here, you know, it just clamps down. Let me see if there's a picture in your book of a vise. Oh, come on. I don't see one, but we'll probably have one there, a small vise. So that just basically locks in. It's like a clamp, okay? So you see that C-clamp, well, picture a vise on a heftier level, solid metal and just big, and it clamps your work and holds it steady. It also can be used to pound on if you need to bend something. The hardy we talked about, which, you know, is just for tamping or hitting your metal or even cutting it if you had to. Then decorating it, yeah, putting marks in it. Tongs, we talked about those, you know, they're pretty long. And there's a picture right there of the tongs. Kind of like what you have in your kitchen, just a little more heavier duty. The hammers, obviously, those are different types. The ball peen and the sledge is what we use here. And then the forge, what creates your heat or what you put your metals into. So, and does everybody understand hardening, work hardening? Because that's one of the most important things. There are soft metals and there are hard metals, okay? So, for instance, a file, okay? What would a file be? That would be a hard metal, because what does a file do? It cuts other metals. So if you were to try to file a file, basically you're using the same hardened steel, and it wouldn't be too successful. But if you took some alloy or some softer metal, the file, because of the way it was designed and tempered, again, is able to cut that softer metal. Your saw blades, your chainsaw blades, things that are made for cutting or coming, chainsaw doesn't come in contact with other metals, but things that are made for cutting or coming in contact with things like that. And a good example is, I don't know how often you guys go to Home Depot. I'm there usually every other day, but if you ever get into the Home Depot, go look at the saw blades. They have some for wood, they have some for block, and they have some for metal. So each one of those was tempered a different way, processed a different way, so that it becomes either harder or, it's not so hard, because you don't need a super hard one for wood. So again, the metal ones have to be much, much harder and tempered harder. So again, just some examples. Any questions? Okay, this is the part where I say you've been a fabulous audience. We look forward to seeing you on Saturday. Again, you're a morning session. So when you arrive on Saturday, make sure that you're gonna go through check-in. Miss Andrea will take your temperature and log you in and ask how you're feeling. And then obviously if you're not feeling well and you know the process, don't show up, give us a call. This shouldn't be hard, it should be fun, it should be an activity that you can come and enjoy yourself and be outdoors, okay? She talked about the shoes. It's just for in case we drop something or you drop something, you don't want to hurt your foot, okay? I have a really thin pair of Nikes that I love to wear, but I'm gonna have to wear my boots for that day because I don't want any of you to drop anything on my foot, okay? Like in welding, that's totally different. Well, you can have sparks flying all over the place. Same when you're pounding on metal, you get little flakes of steel flying here and there, so not as much as in welding. Okay, wear your face covers. We will have extra if you forget yours, but it's rare. I'm sure it's habit with you, but it's very important that you wear those. And then we are providing leather gloves, goggles, and aprons to protect yourself. Bring some water so that you have something to drink. We have a light refreshment stack after you're done. If anybody's allergic to peanut butter, please let Miss Andrea know, because I think they're peanut butter and jelly sandwich. You know those Uncrustables? real soft. Okay, so with that, are you done? You want to say something? And Miss Andrea wants to say
All
something.
right. So again, are there any questions at all that we did not cover or that you think are necessary to know?
Yeah, so for option 4, blacksmith, when it says make a sketch of the 2 objects to hot forge, are we doing that?
For that, again, because of the conditions that we're in, we will make a sketch. What we're going to try to do is work with one piece of probably 18 gauge steel, and then we're going to do everything off this piece of steel. So you might have a 3-foot piece or a 2-foot piece, and we're going to temper it on one end, and then we're going to draw basically a hook or a handle, and we're going to bend and shape it as we go through the process. So that, like I said, we won't be here like at Trask where we have all these different size thickness of metals. We even have railroad ties, you know, those little railroad spikes. Those are always fun to heat up and pound. And I apologize for that, but under the circumstances, it's going to be as simple as possible. But we want you to get the idea of how the process works, okay? So again, we will have steel there for you to bend. We will have a project there for you to do. And if we're going to draw anything out, we'll draw it there that day.
So like Anthony said, in the book on page 79, they talk about the project of making a cast iron Dutch oven lid lifter. And that's basically what you'll be doing is you'll be making that, you'll be, like you said, making a hook on one end of it, and then twisting it in whatever design you want, and then try to make a, like a, maybe not a hook this way, but something where you can hold it on the other end. That's one of the project. The other one is just, like you said, taking that piece of metal and just beating it to death and changing its shape. And then you'll get it hot, and then you'll take it out, you hammer it, you put it back in, you know, you're gonna anneal it, is what it's called, and change its shape, okay? Any other questions? Okay.